It's a rainy afternoon and I'm here by the beach. Hopefully the skies won't pour on me, but I'm about to look at physics paper 1 from the year 2021. Okay, so that's that. Okay, that's the face of the paper, and that's like the rains are about to start. If they start, I'll run away and I won't switch off the camera so that you see the speed, the velocity I'll be running at. So that's physics, our physics 2021 right there, 16th November, paper 1, physics. Maniepa Siazibulo is my name, physics 5054, ECZ. Let's get to question 1 of this paper. The first question reads, an engineer wants to place a blocked pipe with replace a blocked pipe with one which measures 1.8 millimeters thick and 3 meters long. Which of the following measuring instruments are the most appropriate? It's a measuring tape. If you say meter rule, it's 1 meter long, but look at the length of the pipe, it's 3 meters. A tape can even go up to 12, up to 20 meters, up to 10 meters. So a tape is much more appropriate because a ruler will mean you have to move it to disturb your accuracy. Then look at this one, 1.8 millimeters up to 1 decimal place of a millimeter is the accuracy of the thickness of this pipe. Therefore, an instrument that has got this degree of accuracy is the vernier calipers. For a micrometer screw gauge, there are 2 decimal places here, so our answer there comes out as B. Number 2, by the way, I'll go up to question 20, then I'll do the other half later on. The diagram shows the distance time graph of a bicycle. The diagram shows the distance time graph of a bicycle. At which labeled point is the bicycle moving with constant speed? Constant speed. You have to look at and understand how a distance time graph is read. A velocity time graph is different from a distance time graph. Therefore, any change in the y means there is change in distance. This bicycle is moving. Here at A, there is no change in y, so it means distance is constant. The bicycle had stopped. At B, the bicycle had stopped. At D, the bicycle had stopped, but at C, the bicycle was moving. This is the only labeled part where the bicycle was moving. Even here it was moving, but this is the labeled part, and so we label this one because that's what they want us. Don't label where there's no letter. So our answer is C. It was moving at this point here. 3. Which statement about mass and weight is correct? Which of the statements about mass and weight is correct? My answer was mass and weight do not have the same unit. They do not. Weight is a force, the unit is Newton. Mass is capacity, is quantity, and the unit is what? Kg or kilogram. The others are actually not okay. So the first one is different. In different gravitational fields, the mass of an object changes. No, mass is constant. Number B, mass and weight are different types of force. No, mass is not a force in the first place. Then D, mass is weight due to gravity. No. So the answer there is C. Is the one which is correct. Number 4, 2 forces, 3 newtons and 40 newtons act at right angles to each other. Which of the following diagrams show the resultant force R? My answer was C. Looking at the way the forces are arranged, my R or resultant would be like this. If they were head to tail, my diagram would have been different, but they are acting at right angle to each other away from a common point here. So the resultant direction of force would be along R. My answer is C. Question 5, a force of 1600 newtons accelerates a car of mass 800 kgs from rest. What is the acceleration and its velocity after 4 seconds? So my answer was D. Look at my calculations here. I was trying to work out this, but since this one has got a little bit of it needs a little bit of calculations, I did a little bit of calculations for us to understand how I arrived at 2 here. So my paper is moving. Let me just do that. So on my calculations, then the blue pen, force is equals to mass times acceleration. I make acceleration my subject because I have mass, which is 800 kg in the question, and then I have force, which is 1600. So my final acceleration comes out as 2. So this m is the mass 800, which is this 800. Then the force is this 1600, which is this 1600. 1600 over 800 gives us 2.00 meters per second squared. That would be our acceleration. And then the velocity, they're asking for what is the acceleration and velocity after 4 seconds. They have given you the time, then you have the acceleration, and then they have told you this car is coming from rest, meaning that they have told you the initial velocity, which is 0 because it's coming from rest. So initial velocity, which is this u, is equal to 0 because the car is coming from rest. So I use this equation. Final velocity is equals to u plus at. U is equals to 0, so it's the same as saying 0 plus 2, you still come back to 2. So this one is removed because it's equal to 0, remain with at. A is this 2, then the time is given as 4. So finally, when you multiply 2 times 4 gives you 8 meters per second, which is this 8 meters per second here. So my answer there comes out as D. Okay, it's a little bit windy out here, but beautiful. Yeah. So question 6, the following diagram shows an L-shaped uniform spanner used to turn the nut. This is our nut, that's our spanner. Look at the way it is, 30 centimeters long in this on this side, then 15 on this side. And then the question follows: which of the following is correct if the position of the nut is moved to P? Okay, if the position, therefore, if you use this end to rotate this nut, which one among these is going to be correct? So if you use this end to rotate this nut by by twisting and the like, the force applied will increase because this end here is short. The shorter, this is all about moments, okay, to be like moments. So at this point here, the force will increase because the arm, the effort arm, the arm that you're using to rotate is shorter, so it's easier to rotate when the arm is longer, so you use less force. So since you have moved the nut to P, which of the following is correct if the position of the nut is moved to P? The force applied will increase. That's my answer there. Number 7, what acceleration will a 50 Newton force force produced? What acceleration will a 50 Newton force produce on a 200 kilogram mass of stone? Use this formula. Force is equals to mass times acceleration. A is equals F over M. Then 50, which is our force, over 200, which is our mass, and the acceleration comes out as 0.25 meters per second squared. Our answer is C. 8. 3 objects PQR have different masses and different speeds. Which of the following is the descending order of their kinetic energy? Understand that the following formula for kinetic energy is this one here. K is equals to half mv squared. And so I did calculations. This is for P, this is for Q, this is for R. So you just have to go through. You cannot easily conclude just by looking. So since the formula is easy, this is our mass, which is this 1 kg. And this 2 here is our mass for this 2 kg. Then this 5 here is this here. Then speed, meters per second, they are both moving. This is 3, which is this 3, but since it's squared, v squared, it becomes 3 squared, which is 9. Then 2 squared, which is this 2 here, when you square 2, it gives you 4. When you square 1, it's going to be 1 times 1, which is 1. So after you resolve this, you realize that this one will have the lowest KE, followed by that, then followed by that. And then they're asking for which of the following is a descending order, okay, meaning starting with the highest KE and then going down. So PQR is the answer. P, which is 4.5, Q, which is 4, then R, which is 2.5. Our answer is A. Question 9. A windmill raises water from a well. The depth of the well is 5 meters. The windmill raises 200 kgs of water in a day. What is the power extracted from the windmill? We know to say power is equals to work over time. And we know to say work is equals to FD. So I replace work by using FD because, let me just make my paper date, because work is equals to force times distance. So where there is work, I replace with FD because work, W is equal to this. So this is W. So even here, I replace my W with that. And then since we're talking about lifting water from a well, meaning this is force, and if anything, if you're lifting water from down upwards from a well, from deep in a well, you're actually working against its weight. So this force can actually be said to be weight, force of gravity, weight, force of gravity on the water, which is weight. And we know to say gravity is weight is equals to, which is force, this is work, but this one is weight. Work is equals to force times distance, then weight is equals to mg, okay, mass times gravity, which is this mg here. So this is our mg, this is the same mg because work is equals to mg, so mgd over time. So they've given us that the mass is 200 kgs, which is our m here, and then the distance covered is 5, and then gravity is taken to be 10, which is our g. So we've got 5, 10, and then 200. Then time, they've said the windmill raises to this much water in a day, okay, in a day. So how many seconds? Because we measure time in seconds. Understand that one day is made up of 24 hours. Each hour is made up of 3,600 seconds, because 1 hour is equal to 3,600 seconds. So 600 seconds, this 60 by 60 is this 60 by 60 here, okay. So this is 1 hour in terms of seconds, okay. This 60 by 60 is this 60 by 60. So this is 1 hour times 24 for you to have the actual number of seconds. So the answer here should have been maybe this one by adding a 0 here, okay. So I couldn't find an answer for this question. Let me pause a little bit and go indoors because the rains are becoming more and more. I'll see you in a moment. So getting to question 10, a contributing factor to pressure in a liquid is the temperature, no. Size of the container, no. Shape of the container, no, but the density of the liquid. Okay, a thick liquid will have a lot of pressure on you if you went swimming in it, compared to a lighter or maybe a liquid with less density. 11. A table of weight 600 rests on a lawn using its 4 legs. Do they ever have 3? Okay. The area of each leg in contact with the lawn is 0.04 meters squared. What is the total pressure exerted by the table on the lawn? We know to say the formula for pressure is this one. P is equal to FA. Okay, pressure is equal to force over area. Area in Newton meter squared. In meter squared, then pressure in newtons. So we're told each leg in contact, has this surface area at its bottom there. So there are 4 of them. So I get this area for each leg and multiply by 4 because it's resting on its 4 legs. So my total area, or the total area on which the weight of the table is acting, is 0.16, 0.16. When I do my divisions, the pressure is coming out as 3,750, okay, Newton per meter squared. And it is actually this one here. Although the unit here, I feel like the P should be a capital letter to give us a Pascal. It should be like this. My answer is B. Question 12. The following diagram shows the laboratory thermometer. Okay, laboratory thermometer, and this one is a mercury in glass, not alcohol in glass, but let me just say it's a liquid in glass. Okay, liquid in glass thermometer, capillary X, so region X in the capillary tube represents a vacuum, not alcohol. They've already told us it's mercury, it's having mercury, not steam, not water, it's a vacuum. And the reason why it's a vacuum is to give room for the mercury to expand freely. If there was air in here, the expansion wouldn't be easy because there's already air in the space there. So it's a vacuum. Question 1.3, which is 13. The following diagram shows hot water at the top of the rest of the tube. What? Let me read that again. The following table shows hot water boiling at the top of the test tube while unmelted ice remains at the bottom. This is hot water boiling. There's a gas here because ice can float. So the gas is to prevent ice to come to the top there. It will melt. So to keep it down here, they put a gas and there's ice here. And then they hit midway of the tube and apparently the water begins to boil here, and down here nothing is happening. Okay, the ice is still solid. So this happens because water is a poor conductor of heat. Therefore, hot water rises because its density becomes less. So the fact that hot water rises, it will create convectional currents. Convectional currents just up here. Okay, it will not really go down. Okay, it will not really go down because hot water and even hot air rises. Okay, and then cold water sinks. But again, when I say cold water, the water is at its densest at 4 degrees. Below 4 degrees, again, water loses its density. It begins to expand. The unusual expansion of water. So the answer here is D. Water is a poor conductor of heat. 14. A grade 12 learner uses an electric kettle. Okay, an electric kettle. 200 grams of water at 100 degrees Celsius is converted into steam in 300 seconds. The specific latent heat of steam is 2250 joules per gram. When I was solving this, I was almost getting confused because I wanted to convert the mass to kgs, but I realized this latent heat is given to me in grams, joules per gram. So you should be cautious. Look at the question twice and see if the latent heat is given to you. These are constants. They're already calculated for you. Okay, but they can still ask you to calculate or determine it. But the thing is, be cautious because it may be given to you in joules per kg or joules per gram. So here they have given you in joules per gram. So don't convert this one to kgs. So what is the average electric power used? The formula is this: power is equals to energy over time, or work over time, but I'm looking at it from this point here. Energy over time, because I'm looking for energy. So power is equals to energy is this one here, okay, latent heat, okay, latent heat mass the energy. The formula for latent heat, the energy used up during the whole process. So the expression, they're not looking for the answer, but the expression. What is the average what is the average electric power used? Okay, so we want power. So instead of solving, it's like you leave everything hanging. So I know to say energy, the formula for latent heat, they're saying 200 grams of water at 100 degrees centigrade is converted to steam in 300 seconds. Okay, this water is already at 100 degrees. So they just want the energy it takes for all of this water to be converted to steam just after it reaches what? 100 degrees. The story would be different if the water was at 80 or 40 degrees, but it's already at 100 degrees. So at its boiling point, just after reaching its 100 degree, after reaching its boiling point, come on. My mind knows what it wants to say, but my tongue is going is whatever, man. So that's that. So the energy it would take for this much water to be converted to steam from the point when it just becomes 100 degrees Celsius would be this much. So do not complete it because they want expression. So energy is equals to this. This is the formula. So 22250 over 300, and this is 22250 over this here. Our answer is B. Number 15. What term is used to describe the number of crests of a wave passing through a point per second? Frequency. Number 16. Which two types of electromagnetic radiation are used to kill cancerous cells and detect cracks in metals? Gamma rays and X-rays. Okay, gamma rays and X-rays. 17. Sounds are produced by vibrating objects. A certain object vibrates, but a person nearby cannot hear any sound. Which statement could be true? Why nothing is heard? The frequency of the vibration is too high. That was the most appropriate answer, because there is ultrasound and there is sub-sound or subsonic. Sub-sound. Sub means more like subwoofer, but sub means a sound whose frequency is below the hearing frequency range for humans. Therefore, there are animals like whales and elephants, the big animals, who can hear these heavy bass sounds. But again, there are sounds that are just too high, supersonic or supersound or ultrasound, and this is the one which is here. Vibrations were too high. I mean, the frequency of the vibrations were too high. Our answer is B. 18. The following diagram shows sound waves displayed on a screen of a cathode ray oscilloscope. Which sound wave is getting louder and has a pitch that is decreasing? So you have to know how to read waves, the wave profile diagrams. Pitch decreasing means the wavelength becomes longer, okay, and then loudness means the amplitude becomes greater. So look at this. The wavelength from there to there is shorter compared to the wavelength from there to this point here. So this wave from here to here has a longer wavelength, and then from there to there it's shorter, meaning the frequency is getting the pitch is decreasing. Frequency directly affects pitch. A sharp sound can only come from an object that is vibrating at a very high frequency. So our answer is this one here. Amplitude represents loudness or intensity. Then frequency affects pitch. The higher the frequency, the higher the pitch, and vice versa. Our answer is B. 19. Our second last, I'll do the first 20, then I'll do the other one in the second video. A ray of light strikes a plane mirror at an angle of incidence 20. What is the new angle between the incident ray and the reflected ray if the angle of incidence is increased by 5? Okay, this angle here at first was 20. Angles are measured against the normal, this dotted line here. So if we increase this angle by 5, it's going to be 25. And then they're asking if the angle of incidence is increased by 5 degrees, what is the new angle between the incident and reflected, meaning between the incident and the reflected? So this one will be 25 against the normal, and this one will be 25 against the normal from there to there. From there to there, total will be what? 50. Our answer is D. Number 20, our last question for now. The diagram shows an eye looking at a point X at the bottom of a dish of water. The observer seems to see the object at point Y. Okay, these are mostly referred to as optic illusions. Okay, the way we are not able to see properly because we're looking through a media of different density. Even when it comes to air, sometimes when you're driving on a hot road, when you look just above a hot brazier or fire, or maybe you look at if you have a chance of going to a desert on a hot day at a distance, you are able to see illusions that appear like there's a little bit of water, okay, and that's just because there's change in density in the media and our eyes can perceive that. Why do you think we can't see properly in water? It's because of difference in density and how we've been programmed to see only in air. Air is a fluid, water is a fluid. But if you stay very long in water, okay, you stay many minutes, eventually you start adapting and you'll be able to judge distance better and to figure out shapes of things after you stay a little bit longer, provided the water is clean, not murky. So this is our diagram. I've even forgotten the question. Let me go through again. The diagram shows an eye looking at point X at the bottom of a dish of water. The observer seems to see the object at point Y. Okay, so the object is at C, the observer is seeing it at point Y. This is the reason why people or bushmen used to fish using spears would always throw the spear a little bit ahead from where they are seeing the fish, because the fish could be somewhere here but it will be appearing here because you're looking at it from an angle. So you throw your spear or arrow, shoot your arrow just a little bit ahead of the fish. So what is the refractive index of this water? Refractive index is equal to real depth over apparent depth, RD over AD. So our real depth is usually from the top of the surface of the liquid or water in this case up to here. It can even be a glass block. And then apparent depth is from the surface again coming downwards here. They have actually given it to us. Sometimes they may give you from the bottom to Y to this point here, but that's not apparent depth. That is the elevation from the bottom. So depth is measured from the top going down. So this is 12. So it's going to be 16 over 12, giving us 1.33, and the answer is D. I end here for now. I'll see you in the next question 21. Au revoir.